In this problem, a square cross-section of dimension A is subjected to tensile force of P kN, and it is given that on an inclined plane of 45 degrees to the horizontal axis, the normal stress is A into P by alpha into P by A square, and it is required to find the parameter value of alpha. So considering the data, we will draw the picture according to given data. This is the geometry of the problem. And it is subjected to a horizontal force of P and a force acting on the plane Pn, and this plane is at an angle of 45 degrees to the horizontal axis, and this A and A are the cross-section dimensions. And let us assume this width as x1 of the inclined plane and its length as x2. From the given data, we have area of cross-section of inclined plane is equal to x1 multiplied by x2, and the given data is also normal stress on the inclined plane is given as sigma n is equal to alpha into P by A square. From the figure, we have x1 is equal to A and x2 is equal to A by sine 45. Because when you take sine 45, it is opposite by hypotenuse. So x2 is the hypotenuse in the curves, is inclined section, and we have normal force on the inclined plane Pn is equal to sigma n multiplied by x1 into x2. From the above, we have sigma n value as alpha into P by A square multiplied by A into A by sine 45, and this A square and A get cancels, and we are left with alpha into P by sine 45. Now resolving force P along Pn direction, we get Pn is equal to P cos 45, and substituting the values of Pn, we get as alpha into P divided by sine 45 is equal to P cos 45. Here P gets cancels. Finally, when you substitute the trigonometric values, you get alpha is equal to substituting the values for sin theta and cos theta and equating the components. Pn is equal to P cos 45. We have Pn as alpha into P by sine 45 is equal to P cos 45. So P gets cancels and we are left with alpha is equal to sine 45 multiplied by cos 45, and we get alpha is equal to 1 by root 2 into 1 by root 2, which turns out to be 0.5. Therefore alpha is equal to 0.5.